Okay, let's take a look at number 2. We're given that QP is perpendicular to QR. So we know we have a right angle over here. And we need to find the measure of angle PQS, which is this angle here. So if we have a right angle, it's probably pretty obvious that the sum of those two expressions for the angles is going to be 90 degrees. Okay, so simplify here, x squared minus 2x plus 55 equals 90. If we set equal to 0, and factor, this is a quadratic with factor, x minus 7x plus 5 equals 0, we get values of either 7 or negative 5 for x. And before we just go right ahead and eliminate anything, let's just check and see if either of these values makes our angles negative. If I plug in 7 here for x squared, here, I get 49 plus 12, so that's a positive number. And then if I plug it in here, I get 43 minus 14. That's also a positive number, so we're good there. And if I plug in the negative 5, I get 25 plus 12, so positive 25 plus 12 is a positive number. And if I plug in negative 5 in the 2x over here, I get 43 minus 2 times negative 5, so that's 43 plus 10. So that's also a positive number, so we're good. Both of these values work, okay? So both work. And then, so that means we're going to actually have two different possibilities for the measure of angle PQS. Okay, so when x equals 7, the measure of that angle is 49 plus 12, which is 61 degrees. So that's when x equals 7. Or if x equals negative 5, the measure of that is 25 plus 12. So that's 37 degrees. So there's two possible answers for the measure of angle PQS. Okay, let's take a look at number 3. This is a little bit of a different ratio problem than what we're used to doing. The ratio of an angle to its supplement is 3 to 7. Find the ratio of the angle to its complement. Okay, so this is the given information. And then find the ratio of the angle to its complement is what we're trying to answer. So we first need to do something with the given information. And you need to think back to like 5th, 6th grade, probably 6th grade ratio problems. Okay, the ratio of an angle to its supplement. So angle to supplement is 3 to 7. Okay, so the angle to its supplement is 3 to 7. Well, we're going to call the angle x like we always have. And we're going to call the supplement 180 minus x, also like we have been calling. And this is really a proportion that we're going to have to solve by cross-multiplying. Okay, cross-multiplication gives us that 7x is equal to 3 times 180 minus x. So 7x equals 3 times 180 is 540. Minus 3x. 10x is 540. That makes x equal to 54. But the question is, what's the ratio of the angle to its complement? Okay, so if this is the angle, right? Angle to the complement, the angle is 54, that makes its complement 36. If we simplify, we get a ratio of 3 to 2, because they're both divisible by 18. And the last one I'll do here is number 4. The rest of them are really proofs, and we'll cover those when we get back to class together next time. So given the measure of angle 1 is x squared plus 3y, 2 is 20y plus 3, So let's just fill these in. X squared plus 3y, 20y plus 3, and then 3y plus 4x. Find the measure of angle 1. Okay, well, we've got a couple things going on here because I see an x squared, but I also see an x and a y. So it's kind of like, I don't know, a system with a quadratic mixed in, but we really need to take a look at what information we know and go from there. Okay, so if you notice here, angles 1 and 3 are actually vertical angles. So if you remember, vertical angles are always congruent. So that means that x squared plus 3y must equal 3y plus 4x. And look at that, the 3y's actually cancel. So we're left with x squared equals 4x. And be careful here because this is still a quadratic, right? So if x squared equals 4x, we're still going to subtract 4x, set it equal to 0. Factor, in this case it's just a greatest common factor, and solve. So x is either 0 or 4. Okay, so we have our values for x, possible values for x, and on first look it doesn't look like the 0 is going to present an issue necessarily. So how are we going to figure out our value for y? Take a look. We have two straight angles here, and it doesn't particularly make a difference which one we choose to write our equation for. So if we go with 20y plus 3 plus 3y plus 4x equals 180, and then we substitute in, we'll start by substituting in the 4. All right, so let's simplify first. 23y plus 4x equals 177. So if we substitute in the 4, 23y plus 16 equals 177. So 23y equals 161, and that makes y equal to 7. Okay. If we consider the case where x equals 0, then it's a little bit uglier. I got to do it up here because I'm running out of room. So if x equals 0 back here in this equation here, if x equals 0, 23y plus 0 equals 177. So that means y is going to equal 177 over 23. That's rather ugly. Okay, but again, I don't really see any issue with it equaling that in either case. Okay, so we have two values for x and we have two values for y. So the question asks us to find the measure of angle 1. Well, for the pair of values when when x is 4 and y is 7, the measure of angle 1 is 16 plus 21. So that is 37 degrees. Right? And for the pair of values when x is 0 and y is that big ugliness, 177 over 23, then we have that the measure of angle 1 is 0 plus 3 times 177 over 23. So 3 times 177 is 531. So we get 531 over 23 degrees. Okay, and that's pretty ugly. The 37 is certainly a lot nicer. But in theory, it really could be either one because, like I said, I really don't see an issue presented in terms of like making angles negative or anything when we use that x equals 0 as a possibility. And I think that is it. See you in class next time.